everyone. My name is Brianna Burnett, and this lesson is talking about acids and bases. So let's first look at acids. What are acids? An acid is a solution that has many hydrogen ions, so H plus ions. That means it has a lot of positively charged hydrogen ions in it. Notice the formulas below all have hydrogens listed as the first element. So if we look down here at the bottom, we have acetic acid, which is vinegar, citric acid, hydrochloric acid. They all start with hydrogen. So that's typically how we see it. Not always, but typically we've got that hydrogen listed first. All acids contain hydrogen ions and a non-metallic element. So when determining whether or not you have an acid, you're going to look for those hydrogen ions, and you are going to look for a non-metallic element, okay? So as a quick review, which of the following chemical formulas are not acids? And how do you know? So take a second and look through those. All right, so let's go through one by one. We've got HCl, hydrochloric acid. That is definitely an acid. We've got the hydrogen listed first. NaCl, sodium chloride, which is also known as salt. There's not even a hydrogen listed in there, so it's definitely not an acid. H3PO4, so we've got hydrogen phosphate. We've got an H3 at the beginning, so that's very likely going to be an acid. CaSO4, which is calcium sulfate. There's no hydrogen listed here, so that's not an acid. KBr, potassium bromide, no hydrogen, no acid. And then we have H2CO3. We have the hydrogen at the beginning, so this would be an acid. So what are bases? A base is a solution that has many hydroxyl ions, okay? We also call these hydroxide ions. So notice that all the chemical formulas for a base contain OH, which is a hydroxyl ion, and it's the hydroxyl ion is listed at the end of the chemical formula, and it's also paired up with a metal. So another name for a base is alkaline. So when you talk about alkaline metals on your periodic table of elements, we know that those can be bases, okay? So some examples of bases, if you look in the bottom left, we've got KOH, potassium hydroxide. That's soap. Because we've got the OH at the end, we know that we have a base. We have NH4OH, which is ammonia. And because of the OH in the end, we know that this is a base as well. We have calcium hydroxide, and it has an OH at the end, which means there's a hydroxide or a hydroxyl ion. That is lime, and that is a base. And if you'll notice, these things are all cleaners. So a lot of our cleaners that we have stashed in the cabinets that you clean the house with, these are all bases. So as a quick review, the negative ion found in all bases is called the hydroxyl ion, hydroxide ion. And then 2, match the chemical formula with the correct base. See if you can figure this out by looking at a periodic table and looking at the names of these chemicals that are the elements that are in these chemical formulas. So take a second. So NaOH, number 1, that's sodium hydroxide. We're starting with the sodium. So that, number 1, would be paired with letter C. For number 2, we've got calcium hydroxide, starts with a Ca, so that's calcium. So 2 is paired with A. For 3, we have NH4OH. We've got hydroxide ion at the end of that chemical formula. It starts with an N. So even though we would think that it would start with the word nitrogen, this case doesn't, okay? This is ammonium hydroxide. NH4 begins the ammonia chemical formula. Then we have KOH. So K is our beginning element, which is potassium. So we're going to look for potassium hydroxide. So 4 matches with B. So let's look at some different properties of acids and bases. I've got a Venn diagram up here so you can see what's the same and what's different between them. Acids taste sour. They're found in many fruits. So your oranges, your grapefruits, anytime you eat those, your lemons, your limes, and you make that pucker face, you've got an acid, okay? It tastes very sour. And it turns blue litmus paper red. So if you buy litmus paper and you dip the blue kind into the acid, the paper will turn red, okay? Your bases, they taste bitter. They don't taste very good. They are used for cleaners a lot of times, so I definitely don't want to go taste those. And they turn red litmus paper blue. So we've got two different kinds of litmus paper that can test for acids and bases. We've got red and we've got blue. Blue litmus paper will turn red in the presence of an acid. But if we dip blue litmus paper into a base, it's just going to stay blue. So with bases, the red litmus paper will turn to blue. But if we have blue litmus paper and we dip it in a base, it's just going to stay blue. What do they have in common? They're both corrosive. So if you have acids or bases in a very high concentration, they are going to eat through things like metals and wood. They corrode things. They also conduct electricity. So if you need to conduct electricity, high concentrations of acids and bases will do that. For instance, if you've ever made a lemon battery, it's an acid, okay? The lemon acid served as battery acid. So suppose you have an unknown solution and you want to know if it's an acid or a base. How might you find out? We already went over one. Let's look at the rest. So we have indicators. Indicators are organic compounds that change colors depending on if it's placed in an acid or a base. So some types of indicators that we have are purple cabbage juice, we have litmus paper, blue or red, and we have pH paper. This is a lot of information thrown out that if you don't work with it, it might get a little confusing to follow. But let's look at this. Let's look strictly at cabbage juice. So let's look at this column. You can take purple cabbage from the store and mash it all up and boil it in your kitchen to create this really stinky cabbage juice. But whenever you mix the cabbage juice with different solutions in your kitchen, you'll see that the cabbage juice changed color. So it's an indicator. So if you have an acid, if you mix cabbage juice with an acid, the liquid is going to turn a pinkish red color of different degrees depending on how strong the acid is. If you have a base and you dump it into the cabbage juice, you're going to get a bluish green color. So the purple cabbage juice will turn to a bluish green. If it's neutral, your cabbage juice will just stay purple. So if you add water to the cabbage juice, it's just going to stay purple. Looking at the red litmus paper, it's just a little strip of paper. If you dip it in acid, it'll turn red. If you dip it in a base, it will turn blue. It will change colors. If it's neutral, it will turn red. So red litmus paper isn't very good for differentiating between acids and neutrals. It's really only good to let you know if you have a base or not, because it will turn blue. Blue litmus paper, the same as red litmus paper, except in reverse. If you dip it in acid, it's going to turn red. It's going to change colors. If you dip it in a base or a neutral, it's just going to stay blue. So blue litmus paper is only good to show you if you have an acid. And it doesn't tell you the degree or how acidic or basic something is. It just lets you know what you're working with. So here's a more illustrative example of cabbage juice. Again, if you boil purple cabbage, you're going to get a liquid that is this color, okay? It's just kind of like a bluish purple, but mostly purple. If you add acids to it, it's going to turn more pink and more red. The redder it gets, the more acidic the solution is. If you add bases to the cabbage juice, it's going to go more blue and green. The greener it is, the more concentrated the base is. Litmus paper, here's just two pictures of what will happen. In pH paper, this is nice because it's paper like litmus paper, but if you dip it into a solution, it will tell you what the pH of the liquid is, so how strong the acid or the base is. The pH scale is a way to measure how acidic or basic the substance is, and it goes from 0 to 14. Acids will have a number of less than 7. Bases will have a number that is greater than 7. And neutral or distilled water will have just a pH of 7. Okay, so if you look at this picture of the pH scale, pH paper shows you these colors basically. So at a neutral, which is water, you're going to be here, okay? And then as you move up the scale, you're going to get a stronger acid. So the strongest acid is 1. And then as you go down, the base, the strongest base that we have, would go down to a number 14. I'm sorry, that black box keeps popping up. There you go. You can see that the strongest base is a 14. So let's talk about neutralization reactions now. These are chemical reactions between an acid and a base. So you're mixing acids and bases, and that produces a salt and a water all the time. You're going to wind up with a salt and you're going to wind up with a water. So a neutral substance is made when you go through a neutralization reaction, which is why the name has neutral in the name. So a salt, when we think about salt, we think about the little shaker of white stuff we put on our food at dinner or lunchtime or even breakfast. But that's not the only kind of salt there is. Salt is a category of substances that is formed in a neutralization reaction. It's made from the negative ion of the acid and the positive ion of the base, okay? So again, we're taking the negative ion from the acid and the positive ion from the base, and that's going to create a salt. So here's an example of a neutralization reaction. You mix an acid with a base and you wind up with a salt and water. So to be even more specific, if you mix hydrogen sulfate, this is our acid, with sodium hydroxide, which is our base, you're going to wind up with sodium sulfate, which is a salt, plus your water. Whatever isn't your water, if you're mixing an acid and a base together, if you don't know which one the salt is or you don't recognize the chemical formula for salt, it's the one that's not water. So just identify your water first, and then your other one is going to be the salt, okay? So in the second example, we've got hydrochloric acid, which we can tell by the H. We've got our base, potassium hydroxide. We know that from the OH, okay? You mix those two together, you wind up with potassium chloride and water. Since we know H2O is water, potassium chloride is going to be our salt. And that wraps up our discussion on acids and bases. So as a quick review, acids are going to be substances that have hydrogen ions in them. Okay, so whenever you have a chemical formula that lists hydrogen as the first element, that's usually going to be your acid. Okay, and acids fall between 1 and like 6.9 on the pH scale. Your bases are going to be substances that have a hydroxide or a hydroxyl ion at the end. So you're going to have an OH, okay, at the end of your chemical formula. These bases will fall between like 7.1 and 14 on the pH scale, depending on how concentrated they are. Some of the ways that you can determine if a substance is an acid or a base is to use an indicator like cabbage juice or litmus paper or pH paper, okay? All those things can show you if you have acids or bases. And whenever you mix acids and bases together, you wind up with a neutralization reaction. So acids and bases neutralize each other, they cancel each other out, and every time you mix an acid and a base, you're going to wind up with salt and you're going to wind up with water, okay? Two new substances, a salt and a water. So I will see you soon.